and welcome back. Now, in the last video, we implemented movement for the enemy by creating a move to task in the behavior tree. Now, just as a reminder, here's the behavior tree, and we used a sequence node. And because the sequence node only has a single child node, that's the only node that it has to execute, so it just executes the move to node. And it's going to keep executing this move to node because there are no other nodes to execute. Now, before we continue on with AI, we're going to take care of this issue where when the enemy moves, the enemy just sort of floats to the destination, remaining in that idle animation. And that's because if we go to the Grux anim blueprint, we will see that there is only a single animation state. So let's go into the enemies folder and open Grux anim BP. We'll see that we have a locomotion with a hit slot. And in locomotion, we have the idle state, and that's it. We're just playing the idle animation. Now, we can take a look at the Grux animations folder here in Paragon Grux characters, heroes, Grux animations. And if we type run, we'll see that there are some run animations, but there are also some blend spaces. Now, here is a blend space called idle to run. Go ahead and double click that. And it's a simple blend space. It just has the idle animation down here at 0 on the axis. And it has the run forward animation all the way up here at 420. Now, it has a horizontal axis and the name is none for the axis, but it looks to me like this is the speed of the character. So we can name this axis speed. And we can simply use this blend space 1D. So let's go ahead and save that. Now, we're going to use the speed of this enemy character, so we need to have access to that speed. So we're going to go into our anim instance C++ class for the enemy, and that is called Grux anim instance. Let's go to Grux anim instance.h, and we're going to need a variable for the speed. So let's go ahead, and this is a class, and all classes have private bodies by default, so we know this is private, but just for clarity's sake, I'm going to add a private section here, and I'm going to add a float called speed. Now, I want to be able to see this from blueprints, so I'm going to give it a U property. And I'm going to make this visible anywhere, and blueprint read only, category movement, and meta equals allow private access equals true. So we have a speed variable for the enemy. We can give this a comment and say lateral movement speed. Now we need to set this each frame. And we can do what we did in our shooter anim instance. If we go back to shooter anim instance and scroll down, we'll see that we created a function and made it blueprint callable, and that function is called update animation properties. I'd like to do the same thing with our Grux anim instance. So I'm going to copy this and go back to Grux anim instance and add a public section. And here we have our update animation properties. I'm going to go ahead and create a function body for update animation properties. So here is Grux anim instance. Here is update animation properties, and I need to use the Grux anim instance class name to fully qualify this function name. So we have a update animation properties, and this will be called each frame. Now, in order to get the speed, we need a reference to the enemy character. So I'm going to forward declare an enemy pointer called enemy, and I'm going to copy this U property macro and give it to the enemy, except I'm going to remove the category. So now we have an enemy pointer. Now we need to make sure we have a reference to the enemy. So here in update animation properties, we're going to check to see if enemy is a null pointer. Now, if it's null, then we can set enemy equal to the result of a cast to a enemy, which means we're going to have to include that header, so we'll do that. So we'll say include enemy.h, and what we're going to cast is the result of try get pawn owner. So once we call try get pawn owner and cast to a enemy, then enemy should have a valid value. But just in case, we're still going to check to make sure enemy is valid before we try to access the enemy. Now we can get the enemy's velocity, so we can create a local f vector called velocity, and we can set it equal to enemy get velocity. And since we want the lateral velocity, we don't really care about the z component, we're going to zero that out. So we're going to say velocity.z equals 0.f. And we can set the value of speed equal to the velocity's magnitude. So we're going to get velocity dot size. So now every frame, we're getting the enemy, accessing its velocity, zeroing out the z, and getting the magnitude of that velocity and setting that magnitude to speed. Now we have a variable that we can use to drive our anim instance. Let's go ahead and compile this. Okay, so we've compiled, and we can test this out by going into our Grux animBP, and in the event graph, we can call this function that we made blueprint callable called update animation properties. So let's go ahead and make sure we're calling that by right-clicking, typing update animation properties, and calling that. Now this takes the delta time input, so we're going to pass that in. And now that we're updating our animation properties, we are updating that speed variable. So let's go back into the anim graph. And we're here in the idle state. Let's go back out to locomotion. And instead of idle, I'd like to rename this state and call this idle/run. And in idle/run, we can use that blend space. So I'm going to type run, and here is the idle to run blend space. I'm going to drag that out, plug that into output animation pose, and now we have idle to run. And we can drive this blend space using our speed variable. So we can type get speed, get that speed and plug it right in. And now we have a blend space instead of just a single animation. So let's go ahead and compile this and hit play and see how this works. And there goes the enemy. It's running, and as soon as it reaches the destination, that speed variable goes back to 0. And so now the enemy is idling. So we now have our enemy running whenever the speed is greater than 0 and idling when the speed is 0. Perfect. Okay, that's going to conclude this video. In the next video, we're going to go ahead and get into our behavior tree and start doing some more interesting things, so I will see you then.